On September 22, 2023, a commercial airliner approaching Beirut Rafik Hariri International Airport received a GPS signal telling it that it was somewhere completely different from where it actually was. The crew noticed the discrepancy. They cross-checked their instruments. They landed safely. What they experienced has a name: GPS spoofing. And in 2023 alone, aviation safety databases recorded over 1,700 confirmed incidents of GPS interference or spoofing affecting commercial aircraft over the Eastern Mediterranean, the Black Sea region, and the Persian Gulf. 1,700 incidents in a single year, affecting flights you have probably taken yourself. This is not a hypothetical future threat. This is not a classified military scenario. This is happening right now, in the same airspace that carries 100,000 commercial flights every single day. And the aviation system was never designed to handle it. What I am going to show you in the next few minutes will permanently change how you think about the safety of every flight you have ever taken.
To understand why this is happening, you need to understand what GPS actually is and how completely commercial aviation has become dependent on it. GPS, the Global Positioning System, is a network of 31 satellites operated by the United States government that continuously broadcast timing signals to receivers on the ground, in vehicles, and in aircraft. A GPS receiver calculates its position by measuring the precise time difference between signals received from multiple satellites simultaneously. The entire calculation depends on one critical assumption: that the signals it is receiving are actually coming from satellites. They do not have to be. GPS signals are extraordinarily weak by the time they reach the Earth's surface, equivalent to the power of a car's interior light viewed from 20,000 kilometers away. A ground-based transmitter broadcasting a fake GPS signal on the same frequency with even slightly more power than the satellite signal will override it completely. The receiver cannot tell the difference. There is no cryptographic authentication in the GPS signals used by commercial aviation. Any transmitter that broadcasts the right format on the right frequency at sufficient power will be believed. This is not a new discovery. Security researchers identified this vulnerability in 2003. In 2013, a University of Texas team demonstrated live GPS spoofing of a luxury yacht in the Mediterranean, steering it off course without the crew's knowledge, using equipment that cost less than $3,000. The demonstration was conducted with full government authorization as a proof of concept. The concept was proven, the vulnerability remained unfixed, and now, a decade later, military forces across multiple regions have deployed exactly this capability at scale, directly into civil airspace.
The mechanism of a GPS spoofing attack on a commercial aircraft is both technically elegant and operationally terrifying. The spoofing transmitter broadcasts fake GPS signals that tell the aircraft's navigation system it is in a completely different location, sometimes hundreds of kilometers away, sometimes placed directly over a location the attacker chooses. The aircraft's flight management system accepts these coordinates as ground truth. The autopilot begins navigating toward waypoints that exist in completely the wrong location. If the aircraft is in cruise over open airspace, the crew may not notice for several minutes because everything appears normal. The instruments show a valid GPS lock. The navigation display shows a logical flight path. Everything is functioning. Only the location is wrong. In documented cases over the Eastern Mediterranean in 2023, aircraft GPS systems reported positions that placed the aircraft directly over known military exclusion zones, triggering TCAS conflict warnings, confusing ATC radar correlation, and in several cases causing aircraft to deviate from their actual course while following the false GPS track. The most concerning documented incident involved a commercial aircraft whose GPS spoofing was so severe that the navigation system briefly indicated the aircraft was positioned over a civilian airport it was not near, and the FMS began calculating an approach procedure to that airport automatically. The crew caught it. But the question that every aviation safety researcher is asking is not whether a crew will catch it. The question is, what happens at night, in bad weather, at a congested approach, when a crew is tired, and the false airport indication happens to align with a real piece of terrain.
GPS spoofing is one half of a larger problem. The other half is called ADSB, Automatic Dependent Surveillance Broadcast, the system that replaced radar as the primary means of tracking aircraft position in most of the world's airspace. Every commercial aircraft transmits its GPS-derived position via ADS-B every second to air traffic control and to every other aircraft in range. TCAS, the Traffic Collision Avoidance System that has prevented thousands of mid-air collisions, uses ADS-B position data to calculate separation between aircraft. ADS-B transmissions are unencrypted, unauthenticated. Anyone with a $30 software-defined radio receiver can receive them. Anyone with a transmitter can broadcast fake ones. In 2019, security researchers demonstrated the injection of 17 ghost aircraft into live ATC radar displays using ADS-B spoofing equipment, causing the display to show aircraft that did not exist on collision courses with real aircraft that did. The demonstration was conducted at a safety conference with government observers present. The vulnerability it demonstrated has not been structurally resolved. The aviation system responded by issuing advisories recommending crews cross-check GPS position against other navigation references. Cross-check your instruments. That is the current primary mitigation for an attack that can simultaneously compromise GPS position and the ADS-B system that uses it. The fallback is pilot awareness. In an era of increasing automation, decreasing manual navigation skills, and expanding airspace complexity, the fallback is the most human element in the system.
In March 2024, the FAA issued a formal safety alert to all U.S. registered aircraft operators, warning of GPS interference at levels sufficient to cause navigation system errors affecting flight safety. It was the most direct official acknowledgement to date that the threat had reached operational significance for civil aviation. The alert did not make mainstream news coverage. Eurocontrol, the European Air Traffic Management Organization, has been publishing monthly GPS interference bulletins since 2022. The bulletins document the geographic spread of interference. In January 2022, interference events were concentrated in the Eastern Mediterranean and Black Sea. By January 2024, the documented interference zones had expanded to include parts of the Baltic, the Middle East, Central Asia, and approaches to multiple major European hub airports. The geographic expansion follows the geography of conflict. Every region where electronic warfare is being conducted between military forces, the interference bleeds into the adjacent civil airspace as a physical consequence of how radio frequency propagation works. The signals do not stop at political boundaries. Military GPS jamming and spoofing designed for battlefield use propagates outward in every direction, into commercial corridors, across international airways, towards civilian airports. The militaries deploying it are not targeting civilian aircraft, but physics does not distinguish between intended and unintended recipients of a radio signal. The International Civil Aviation Organization, ICAO, convened a dedicated GPS interference working group in 2023. Their recommendations include mandatory backup navigation systems independent of GPS for all commercial aircraft by 2030. 2030 is 6 years away. Between now and then, every flight operating over affected regions is navigating through airspace where the primary navigation signal cannot be fully trusted, and the backup is a pilot's awareness that something might be wrong. The sky you fly through is not the controlled, monitored, protected environment you were always told it was. It never stopped being a contested space. We just stopped talking about it. Follow for more about the invisible systems that keep every flight safe and the points where they are more vulnerable than anyone admits.